and it looks pretty much like this. The graph is going to have three x-intercept points. In other words, it crosses the x-axis in three places, and that will be at -3, 0, and +3. And it curves like this. It comes from down below, goes up, curls under, comes under, goes back up again. It has a nice symmetry to it. And in fact, if you look at it, you can imagine if you took the right half and spun it 180 degrees, you would get the left half. Or if you just took the whole thing and rotated a half circle, then you have the same graph. That's a type of symmetry we call point symmetry, and makes this function an odd function. So that's just some terminology you'll learn about later, but I'll just foreshadow it here. All right, now what makes this a function? Now, a function has a single output at most for every possible input. Matter of fact, this equation, no matter what x you put into it, you're going to calculate a single y value. So actually, in this case, you can plug in any x you want to, and you're going to get a single output value y. So that qualifies it as a function, mathematical function. In terms of graph-wise, it means that if you pick an input value, there's a single output, and so if every vertical line you could draw through this graph hits it in at most one place, then it is a function. So that's another statement of the vertical line test, but I'll recap that at the end of the video. Alright, so this is an example of a function. Now, you might well wonder, what is there to be excited about with functions? Okay, well, we're going to explore them in this chapter, and there's some other kinds of features we can talk about. We can think about symmetry, we can talk about rising and falling of functions, their shapes, and we begin to analyze these things, and ultimately near the end we'll see about what happens to the graph of a function when you change something in it. What does that do to the graph of the function? So those are called function transformations. That's a pretty big chapter on functions, and it's a traditional topic for college algebra. But so one reason we get excited about functions is because they're simpler than just plain old relationships. A function is a special kind of relationship that is simpler. There's one output, no more than one output. So that sort of removes ambiguity. In fact, the keys on your calculator are function keys, the ones that do things. Like, for example, the sign key. S-I-N. Its sign is spelled S-I-N-E, but it's abbreviated S-I-N. You've got one on your calculator, and right above it is a key that reads S-I-N with a little -1. At least most calculators have this, scientific calculators. So that sign with a -1, we call that inverse sign. And the inverse sign is programmed in your calculator to be a function. But you could define that as a relationship which would have infinitely many outputs. So let you ponder that for a while. It is possible for every input to have infinitely many outputs. And it's as simple as this. Every time you go around a circle, you come back to the same output value. And so, for example, the inverse sine of 1/2 is 30 degrees. Add 360, you get 390 degrees. Add another 360, you get something else. There are infinitely many outputs there that would fit the inverse sine of 1/2. Well, it's the bottom line. Your calculator is programmed to treat that as a function with a single output, and so that makes life a lot simpler, because how would a calculator give you all the outputs? All right. So anyway, let me erase the board one more time, and I'm going to recap the vertical line test. The vertical line test. Here's one way to state it. If no vertical line intersects a graph in 2 or more places, the graph is a function. And so recall my my graph of this cubic polynomial I had up a minute ago, no vertical line intersects this in two or more places. It is a function. In other words, you have at most one output value. All right, now there is another way to state the vertical line test. If a vertical line intersects a graph in two or more places, then it's not a function. Then the graph is not a function. So the graph is not a function. The picture you might have in your head is that picture of the circle. That's the circle is not a. Oops, I wrote picture, didn't I? Should not try to write and talk at the same time. Graph is not a function. Okay. So a circle, you can draw a vertical line through it. It hits in two or more places. Well, it hits in two places in almost every case. Here's another example. If I had a sideways parabola like this, that would violate the vertical line test. In other words, you could draw a vertical line through it. It would hit in two places. It is not a function. So anyway, two different ways to state this. It's just kind of nice to know this, and you can visually look at it. Now, it's usually a lot more challenging to look at an equation and determine if it's a function or not without looking at the graph. So that becomes problematic. If you don't have the graph, then you may or may not be able to easily tell if you have a function or not. But anyway, it is a feature that describes what a function is. And for every input, there is no more than one output. So anyway, at any rate, let's move on to a little bit more about functions.